everyone, welcome back to our TxePrep video, and in this video we're going to look at the USACO 2021 February contest bronze problem number 2, Comfortable Cows. So the question basically states that Farmer John's pasture is a 2D grid of cells, and Farmer John will add cows one by one, and they will occupy a cell where x, y, and y, like x, y, and y, y, where x and y are between 0 and 1,000 inclusive, and for each cow that is added, we want to add the number of comfortable cows after the ith cow is added to the pasture. And a comfortable cow is basically a comfortable when it is horizontally vertically adjacent to 3 other cows. So in the input, we're basically given n as an integer n, and then the n cows and their x and y positions. And for their output, we're supposed to basically describe how many comfortable cows exist currently. So let's look at a coordinate graph over here, and I create basically a very rudimentary coordinate graph between the ranges of 0 to 4, because the input is between 0 to 4. So now that I have now I'm going to basically plot the points one at a time and see which ones are comfortable or not. So the first point is 0, 1. So that will go, 0, 1 would go over here. And at this point we see, well, there's no cows surrounding this, so we know that this is impossible to be comfortable. And the next point we get is at 1, 0. So I'm going to move this. Yeah, so I'm gonna move this to 0, 1. And we still see over here that these aren't comfortable because there's no adjacent cows to any one of these. The next cow goes at 0.11. So this will go over here. And at this point we see, well, this cow over here, we check that it has a cow on the bottom and a cow on the left, but that's not 3 cows adjacent to it, so we know that that's not comfortable yet. But then our next cow is at 1, 2. So we can take this cow at 1, 2. And now all of a sudden we see that our cow at 1, 1 is comfortable. But by adding 1, 2, how would we know specifically to check 1, 1 and see if it's comfortable? Well, the only cows that are affected by adding a new cow are the cows that are directly adjacent to it. So let's say that there was a cow over here, and let's say there was a cow over here, right? Well, then by adding this cow over here, we need to check, well, is this comfortable? Is this comfortable? And is this comfortable? And then we also have to make sure that we check the original cow that is actually being added. And once we do that, we can basically find out whether the new cow impacted a comfortable cow or not. So that's how we can count the number of comfortable cows. But how exactly would we figure out whether or not a cow stops being comfortable? And the way that happens is when it suddenly has four adjacent like cows next to it. So now that we continue on with the sequence, so now we get 2, 1. So I'm going to move this to, this is at 2, 1. So this goes to 2, 1 over here. And now by adding this, all of a sudden, I look over here and I see, well, now this cow that used to be comfortable is no longer comfortable because I added this cow to 1. So the algorithm for checking if a cow stops being comfortable is to check the surrounding cows and see, does the number of comfortable cows become 4? And if that's the case, then we know that it's not comfortable anymore. We can subtract 1, or we can basically just take it out of our list of comfortable cows. So if we keep on continuing on with this, we see we have 2, 2 over here. So I'm going to just basically mark an X at 2, 2. And we see that now nothing is comfortable, right? We see that it's not comfortable. And now we go to 3, 1. So at 3, 1, we notice that this cow over here becomes comfortable. So now we have 1. And then after that, we go to 3, 2. And we notice that now these 2 cows over here become comfortable, so now we output 2. So now let's actually try programming this, and then we can continue on with this. So now let's actually look at the code. So I'm going to have 3 packages that I include, which is basically the iostream, vector, and set packages. And actually the vector wouldn't be necessary, but I'm going to use namespace standard. And I'm going to do constant integer max, and that basically represents the maximum bound of x and y. So over here I can see that x and y would be between 0 and 1,000. I'm just going to have 1005 just for like safety or like redundancy's sake, so that I don't have any index of out of bounds errors. And what I'm going to have over here is 2 arrays, dx and dy with size of 4. I'm going to explain how these work later. For my data structures, I'm going to have integer n, which is basically the number of cows that will be added. And then I'm going to create a boolean present, a boolean 2-dimensional array called present. And the reason why I'm doing that is I'm going to represent whether each cow is on the grid already or not. So for example, present at 0, 0 would indicate that a cow is already on the grid. While at present 0, 0 equal to false would represent that a cow is not on the grid. And over here, I'm going to create a set which contains a pair of integers, and I'm going to call it comfy. And what that represents is whether a pair of integers x and y are comfortable or not. So for example, if I have the pair 0, 0 inside of this, then I know that they're going to be comfortable. And if I don't have them, then I know they're not going to be comfortable. And since a set contains only unique values, I can basically output comfy.size at the end of each of my iterations of adding a new cow and basically find the number of cows that are actually comfortable. So I'm going to look at these two functions later, but let's go to our main function where I'm going to input n. Then I'm going to set the entire present array to false. Just make sure every value in that array is false and ensure that there aren't any outliers that are true. And I'm going to create a for loop which between from 0 to n and have the iterable value being called I. And the reason I'm going to do that is basically just to input the values and calculate the number of comfortable cows for each n. So the first step I'm going to do is I'm going to input a and b. And a and b are basically representing the x's and the y's. So for example, 0, 1 or 1, 0. And the next step I'm going to do is this peculiar kind of function over here, or kind of block of code over here. And it's basically a loop from 0 to 4 with the value of d. And what that does is it creates two integers x and y, which are a plus dx of d, and y is equal to b plus dy of d. And what that represents is if we go back to these arrays over here, it represents going up, left, down, right. So for example, dx of 0 and dy of 0, so dx of 0 is equal to 1, while dy of 0 is equal to 0. And what that represents is I'm going to take my current point, which is AB over here, and shift it to the right by 1. And I'm going to check that point, right? Because we want to check all of the adjacent points. And then, for example, dx of 1 is equal to 0, while dy of 1 is equal to 1. And what that represents is I'm moving my point up by 1, because my x is staying the same while my y is moving up by 1. And this array basically just serves to efficiently check each of the adjacent cows without manually programming them individually. And what I'm going to do now is I'm going to check, well, is it valid? And if it's comfortable, then I'm going to erase it from the set. And the reason I do that is before I have present of AB is equal to true, I'm going to do that before I even set it to true. So the computer doesn't know that the point AB has been added yet. So if I add that point and it's adjacent to one of these cows, then all of a sudden they have a total of 4 comfortable neighbors. But before it's added, if they have 3, that means that when I add it, it'll have 4, and by that time, it won't be comfortable anymore. So I'm basically going to check that and erase those cows that have those adjacent cows that are comfortable and have 3 adjacent values. And my functions for isValid is basically I'm going to check, well, is it between the ranges of 0 to 1000 that are outlined over here, right? And that's basically all I'm going to check. But for isComfy, it's a bit more logic. And I'm going to check, well, first of all, is the cow even existing? If it's not existing, then I don't need to check it. And I'm going to create a value of adjacent and basically count the number of adjacent cows. And that uses the same logic as before, where I check each of the adjacent cows to the cow that I'm currently checking. So if there's a cow XY, I'm going to check each of the adjacent values to it. And I'm going to say if it exists, if it's present, then I'm going to increment adjacent. And at the end, if I find out that adjacent is equal to 3, then I'm going to return true. And if it's not equal to 3, then I'm going to return false. So if I go down here, if it turns out that this cow is comfortable, then I'm going to erase it from the set. And now after the logic is executed, I'm going to set present of AB to be equal to true. And over here, I'm going to repeat the exact same logic as I have over there. And with the key difference being now I'm going to insert it. Because now after adding this cow, if any of the adjacent cows now are comfortable, because meaning they have 3 adjacent cows, then I'm going to add them to the comfy array, comfy set. And I'm also going to check, well, is the cow that I just added comfortable? And if that's the case, then I'm also going to add it to the set. And at the end of each, basically, iteration of I, I'm going to output comfy.size. And now let's actually run this and see what happens. So I'm going to take this, and I'm going to run it. I'm going to print it. And we see over here that we do get what we want. So for example, we see 0, 0, 0, 1, and then 0. And then for the last one, we see we end up with 2. So if we submit this, let's actually submit this, and we'll see what happens. So here I am ready to submit my program, and I'm going to submit the solution, and it's going to grade it, and we'll see what happens. So it looks like we passed the first. Looks like we're passing the first 2 test cases, and we got it all the way to test case 11, and now we're going to get test case 12, and then there we have it. So kind of in recap, what we did was we input everything, right? And what we did was we checked before we set the current cow, before we told the computer that the current cow exists, we checked all of the adjacent cows to make sure that if they were comfortable, we would erase them. Because by adding a new cow, then they would no longer be comfortable. So we basically did that preemptively. And now what we did after that is we checked all the cows after adding it. We checked all the adjacent cows after adding it, after adding the current cow. And we saw if they're comfortable. Now, if they had 3 adjacent elements, then we would add them to our comfy set. And at the end, we would basically output comfy.size. And that's basically the logic for this specific question. I'll see you guys in the next video.